So share screen. There it is. Share screen. Great. Okay. This one says to write, you've probably got it up in front of you. Yeah, write the standard form equation of a circle. So the standard form equation of a circle is x minus h squared plus y minus k squared equals r squared. Have you seen that before?
Yes, I have.
Okay. So we're just substituting, and this is h, this is k, and that's r. So this is just to put the numbers in type of deal. So here it's y minus a minus 5, so it's going to be y plus 5 squared equals 5 squared, or you can change that to just be 25.
All right.
All right, so let's go to number 2. Number 2, the uh, equation of the circle. Again, it's if you don't get a reference sheet, it's good to write these each time you do the problem. That way you get it down. This is x minus 11 squared plus y minus 7 squared equals square root of 38 squared, which is just 38. All right, number 3. So you can almost just start writing it's x minus 10 squared plus y minus 0 squared equals 8 squared. This one we're going to do a little bit more simplifying on. This y minus 0 squared becomes y squared equals 64. That's your final on that.
Okay.
Okay, same thing here. Becomes x plus 7 squared minus a minus 7 plus y minus 3 squared equals 6 square root 2 squared. So when you're squaring this thing on the right, you square the 6 and you square the square root of 2, which is 2. So this becomes 72, and then you just bring that stuff down with you. Okay, so finally some ones that are different and more difficult.
Oh, she only wants us to do 1 through 6, and then do 9 and 10, and then 12 through 18 even.
Okay, I think I've got them down there.
Yes.
Okay, so the center is still HK. Great. So there's a center of the circle, and then there's a point on the circle. Okay, I don't know where they are relative to each other. What is this called? This thing right here. It's the radius. To find the radius, you need to find the distance between 2 points. You need the distance formula. That's y2 minus y1 squared plus x2 minus x1 squared, square rooted. Maybe your book has x's first instead of y's. It doesn't really matter as long as you do them in the right order, like 18 minus 14 squared, negative 14 minus a minus 12 squared, square rooted.
Oh, I see.
Okay, so this first one, it becomes plus 12. So sometimes you just write the simplification under here. So it ends up being minus 2 squared, which is 4, plus this is 4 squared. I should write there 4 squared, which is 16. So this becomes the square root of 20, and that's your radius. That's this right here. Your radius is the square root of 20. So now we're back to the first 4 problems. We just write them right out the formula, or just substitute in for the formula. So we got x minus 14 squared plus y plus 12 squared equals the square root of 20 squared. And so that on the right there, that becomes just 20.
Okay.
Okay. The next problem here, number 6, is very similar. We have to find the distance between those 2 points. We have h and k. we have the point on the circle. So to find the distance between the distance formula again, it's maybe I'll do it more traditionally. X2 minus X1 squared plus Y2 minus Y1 squared, square rooted. So I'm gonna just it doesn't matter again. So it'll be like minus 13 minus a minus 14 squared plus 1 minus 1 squared, square rooted. So this becomes minus 13 minus a minus 14 becomes minus 13 plus 14.
Okay.
You're squaring that, so just 1 squared plus this is 0 squared. So this becomes just 1. Okay. So that's your radius. It is the distance, but it is the radius in this case. So it's I'll just write it one more time. X minus h squared plus y minus k squared equals r squared. Okay. So that's x minus I'm sorry, x plus 14 squared plus y minus 1 squared equals 1 squared, or just equals 1.
Sounds good.
Yep. Okay, so we're moving on to 9. Is that right?
Yes, 9, 10.
Okay. So this is our first look at an ellipse. I'm going to get a reference sheet going, and I'll send you a link to one because we're definitely going to need it here. Because it wants you to find the center, vertices, co-vertices, foci, length of major and minor axes, and the eccentricity of this. Okay. Let's see if I can find it. Okay, I found my favorite one, and I'll be sending that to you through the chat. So I wanted more chat. Okay, so I'd recommend pulling that up. I'll snip in from it.
Okay. Just open it up. I'm gonna bookmark it.
Okay. All right, so I'm snipping in here all the formulas for ellipses. There's 2 types. There's vertical major axis, horizontal major axis. How do you decide which one it is? Well, it doesn't say it down here, but A has to be greater than B. So the whichever one is the bottom, whichever number is bigger is your A. So that's A and that's B. And that tells you which one is. If A is under the Y, it's the vertical major axis. If A is under the X, it's a horizontal major axis. So that's how you figure this out. So we're just going to run through the list here. The center is H comma K, right? The H is the value which makes this equal to 0. Some students prefer to remember it as the negative of this number. It's 2 comma negative 10. That's H, that's K. All right.
All right.
Then the center, I'm sorry, the vertices are H comma K plus or minus A. So we now have to find A. Well, A squared is 64. So that means that A equals 8. You follow that?
I do.
All right. So now the H is 2 comma and then K minus 10 plus or minus 8. So there's two. This results in 2 pairs. 2 comma negative 10 plus 8. 2 comma negative 10 minus 8. This becomes 2 comma negative 2 and 2 comma negative 18. Not really sure what it means by co-vertices. So I'm gonna look at the answer and maybe it'll clue me in into what it wants here. Okay, so the co-vertices, it's how do I describe this here? It's kind of related to what we just did, but it's so there's usually like 4 points that you care about on an ellipse. that they're referring to. So that wasn't drawn very well. There it is, right? That. So they also talk about these top and bottom ones. So it's like we found these, and they want these too. So how do you find them? Co-vertices. All right. So the co-vertices are. This is a little weird. It's H plus or minus B comma K. So in your problem, that becomes 2 plus, and then B, if we look up here, is 7. 2 plus 7, 2 minus 7, comma, -10, comma, -10. Okay, so that becomes 9, comma, -10, -5, comma, -10. So a lot of these you can just write down. I mean, there's not really a ton of work. There's not really a ton of work that goes with it. So all right, so we can move on to 10, I guess.
Yes,
I'm
please.
kind of flailing here a little bit. 10 is, oh no, I'm sorry, we're not even close here. There's so many more things that they want here. I forgot. Foci. So we have to do the foci. The foci, keep going here. The foci is H plus or minus H comma plus K plus or minus C. So that produced, so C we don't have yet. So you get C is A squared equals B squared plus C squared. A equals, well, A in our case is A squared is 64. B is 49. So C squared, or C is equal to the square root of 15. So your H is 2 comma K, which is the square root of, I'm sorry, we don't have K. We have K, -10 plus square root 15, 2 comma -10 minus square root of 15. All right, so that's it for that. What's the next one? Once.
Length of major and minor axes.
Okay, so that's 2A and 2B. So
And
2A, we said A is so that's 2 times 8. 2B, that's 2 times 7. So we got 16 and 14. So that's the major, that's the minor. And eccentricity, the eccentricity is C divided by A. E equals C divided by A. C is the square root of 15 over 8. Okay, so we can shortcut this a little bit depending on what you want to do. As far as doing this, you can see there's just a ton of information here. There's usually 5 things that you need when you look at this. You need H, K, and then you need A, B, and C. And then everything is just writing the formula. So H is 2, K is 7. Now the A is the bigger one. So this is that's there. So and then B is 7, and then we know that A squared equals B squared plus C squared. So 81 equals 49 plus C squared. C equals the square root of 32, which is 4 square root 2. So C is 4 square root 2. Okay. So now that you have these 5 numbers, you can actually just write the formula as long as you know which one you're on. So I mentioned this in the previous problem here. The one that you have here is this one ends up being a horizontal transverse axis. Oops, I grabbed the hyperbola one. I'm sorry, that's not right. I was like, why is this looking so different? All right, so the horizontal major axis here, because A is under the X. Okay, that's the bigger number. That's how you know. So it's this one. So everything we're about to write what you could just grab from the solutions is down there.
Okay.
So I don't know what you want to do. I mean, do you want me to write it out, or do you want us to just go grab it from the solution? Because everything is, once you have these 5 letters, you're just putting these numbers in.
I want to put it all in though.
Okay, what I'm trying to say, Jack, because it is you could I'm gonna just like everything I'm about to write is gonna come is right here. Like all I'm gonna do is I'm gonna snip. Like I'm about to write all of this because I'm just gonna read off the formulas.
All right.
HK, I'm putting the number in. H plus A, H minus A, and so on. So do you want me to write the formulas and put the numbers in, or do you want to? What do you want to do?
First option.
Just this right here.
Mm-hmm.
Okay. All right. Let's get caught up.
All right, I'm caught up. Let's keep going.
Great. All right. What was the next one to work on?
It is 9 through 10. I think it's 12 through 18 even. Yeah, 12 through 18 even.
Okay. So one of the things that when it asks you to sketch the graph is you can just go to Desmos and sketch the graph. Now, do you think you'll have access to that when you
Probably,
take the
yeah.
exam?
I think I will.
Okay. So what I'm going to do is and you just enter this in. I'm gonna graph this for you and then snip that in so you can see it, and then you can decide how much you want to do from that point there. So let me grab the snip of this. You actually just enter in exactly the way you see it. I'll show you that here shortly. Okay, so the graph here, graphs, there it is. Kind of looks like a circle because it is. What is the what are they asking for here? They're asking for the center and the radius. Okay, so the center is HK. So you can actually see from the graph, like the center is right there. But you can also read it off here, HK. It's 4,1 is your center. That's first thing. The radius is the square root of this number, so it's the square root of 5. It's not 5 because 5 would get you way out here, up, down, left, right, all different directions there.
Okay. Is that just vowels? All they want? Oh yeah.
That's all. That's all I want for that. That's all I want for those two.
No, I could just enter the Desmos. We don't fit.
I didn't follow that. I'm sorry. I didn't catch that.
I could just put it up, just punch in Desmos and then draw it out.
Yes. I mean, I'm happy to do as much or as little as you want here. Do you want to do another one, number 13?
Let's just go by evens with 14, 16, 18.
Okay. Excuse me. Okay. This one here, the center is at the origin. H equals 0 and K equals 0 because there's nothing inside that's being written. This is what you kind of another way to look at this problem. X minus 0 squared reduces to x squared. That's why h is 0. Y minus 0 squared is k is 0. And then square root of 30 squared is 30. So that's your radius. So you got to kind of figure out where's the square root of 30. Well, it's between 5 and 6. So it's somewhere there. This one's not too bad. That's why I can just do it right there between 5 and 6, between 5 and 6, between 5 and 6. And you just kind of want to draw something nice like that. That kind of doesn't look like a circle, but you can throw up there. This is the center is 0, 0, and the radius is the square root of 30, which does not reduce.
All right.
16, I think we got to get to.
Yes, please.
Okay. 16, again, you're going to graph it using Desmos. I'll do that as well. This is one of those, just like the ones we just did. They give you the equations, you have to figure out stuff. This is A because it's bigger. So we need those three letters. We need H, K, A, B, and C. So H is -1. -1 makes this 0. K is -3. -3 makes that 0. A is 6. B is 4. A squared equals B squared plus C squared. So A squared is 36 equals 16 plus C squared. So C is equal to the square root of 20, which is 2 square root 5. So you need those 5 numbers, and then you can write all the other stuff that you want. But let me get the graph of this in here. We know that it's centered at -1, -3. That's there. But it's easier once you have the graph to kind of identify some of this stuff. So let me do that.
All right.
X plus 1 squared over 36 plus y plus 3 squared over 16 equals 1. This kind of looks like an egg, if you will, football. I think it's kind of important to see how to enter it into the software. So that's why I'm showing you that. So you can see that -1, -3 is right there. And then there's these are the points. These are there's the vertices and the co-vertices, and that's what they're trying to get you to label. Again, I'll point out that now that we have A, B, C, H, and K, now that we have these 5 values, you can just grab from the solutions the points that they're asking for. They do this kind of small, but let me grab those for you. There they are. So for 16, oops, those are right there. So they're just grabbing the formula and plugging those numbers in to that. Okay, do we need to do 18?
Yes. Yes.
Okay. 18. All right, so we're gonna find those 5 values again. We got H, K, A, B, C. H is 1, K is 2. A squared is the bigger one, so A is 5. B is 2. And then A squared equals B squared plus C squared. So 25 equals 4 plus C squared. C equals the square root of 21. So once you've identified those, you're kind of have everything you need for this. This one also looks like an egg. It's just a different place. So here's the graph of it. Let's bring that in a little bit so you have it on the screen. There's the graph of it, and then again, since we found those 5 values, you can just copy in or just write those values for the different positions, because you're literally just using the formulas, just adding a number, subtracting a number, kind of thing. So we'll put those up here. So you've got them. Okay. So some other stuff to work on.
Yes, please. I'm gonna send you a couple of physics problems I want to get through, and then
Okay, sounds
that'll
good.
be it. That's all I count. Well, I'll work on for the rest of the night. Hold on, I'm sending it right now. Alrighty. Got the screenshots in. About to send you all. Alright, they're sent.
Okay, I'll check for them. There it is. All right, so see some screenshots in here. Any particular order you want to go in?
Nah, not really.
Okay. All right. Well, first one came in is this alternating voltages and currents. Sometimes they make reference to water when it comes to trying to explain these things. I don't know if your instructor has done that, but current is like the flow of water, which is the way a lot of people remember it or understand it, I guess. Should be a better way of putting it. Okay. What is the RMS value of the voltage plotted in the graph? Oh, there's a graph down there. So there's a formula for VRMS. Let me see here. I like these better when they are problem numbers because I can just go right to the problem. Also varies with time. Okay. Let's see if we can find this one. Okay, so the RMS is the voltage of the peak divided by the square root of 2. What is the peak voltage? We're going to go look at the graph. Do you see down there at the bottom? Well, it's not really labeled that well. 100, 20, 40, 65 maybe? It's not great. Why is it? Why don't they give you more visibility? Okay. Did they say to round that answer?
Just express your answer. Volts doesn't really say anything about it.
Okay, maybe I get the wrong one here. It's the peak voltage divided by the square root of 2. Maybe that is the square root of 170.
Okay.
So, well, what's question 2 ask? No, IRMS. Okay. I guess so. So it looks like it's 170 divided by the square root of 2, which is about 120 volts. Might try that.
Correct.
Okay, that's good. Okay, so now part B is asking for IRMS for some sort of figure that you probably click through. So the IRMS formula for part B, IRMS is equal to VRMS over R. And do we know, I mean, it's probably 120. Oh, yeah, it's 120 ohm, 120 ohm resistor. 120 over 120 is 1. So looks like it's 1 amp for part B.
Correct. What's the average power dissipated in the resistor?
So the average power is generally current times voltage. So power is I times V. So it's probably just 1 times 120. So 120.
120 watts.
Yes.
That's correct.
Is there more to this one?
That's the end of that one.
Oh, great. Okay. Because it looks like there's more. Oh, there's more of these. Okay. Graphical analysis of AC voltage. All right. So let's go to this next one. All right. The figure shows a graph of the output from an AC voltage source. Let's look at that. There it is. Okay. Let me grab that graph. All right. So there's the graph. Hooray. Okay. Now let me look for some hints on how to find the max voltage. It's probably just 3, but you might just try 3 because that's just reading it off the graph.
Sounds good. Which one was it again?
It's this one that says the figure shows a graph of the output from an AC voltage source, graphical analysis of AC voltage source, conceptual question.
Which prefer?
The max voltage is just this 3 here because it's graphing.
Oh, I see. That's correct. What's the average voltage of the source?
Yeah, so I think that's the same as before. It's the V max divided by the square root of 2. Although this does something. Oh, average. I see. Wow, this is weird. So they do. I haven't seen this before. I haven't seen this in a while. So V average is 2 V max divided by pi. So it'd be 2 times 3 over pi, which is about 1.91 volts.
Okay.
Give that a try, please.
Incorrect.
How many significant figures? Okay. So then the next option here, oh, the root mean square. Okay, V average. Maybe it's just 0 because that's the center line here. Maybe we're overthinking this. Try 0.
Let me try it. Yeah, it is correct.
Okay,
0.
so that makes more sense. So V average is actually none of this. It's just 0. Okay, VRMS is V max over the square root of 2. So that's 3 over the square root of 2. And that's 2.12-ish.
So 1.2 volts.
2.12.
2.12.
2.12 volts.
That's correct.
Okay, what is the period of the source? So the period is like how long does it take for it to return peak to peak? So the period is 0.08 seconds, it looks like.
Yeah, one more time. What was that?
0.08 seconds.
0.08.
And that's just peak to peak.
All right. I sent you another screenshot because it doesn't show the other two. This next one says, "What is the frequency of the source?"
Okay, so we can do that without too much effort here. The frequency E is equal to 1 over T. F equals 1 over T. So it's 1 over 0.08, which is 12.5 hertz.
That's correct. What's the angular frequency of the source?
So that is like 2 pi F. So part F is W is equal to 2 pi F. So it's 2 pi times 12.5, which is 78.5 for your angular frequency.
That's correct. All right. On to 18.01.
18.01. Okay. Let's see. I wonder if that's part of the original one here. Yep, there it is. 18.01. All right. A current of 1.4 amps. Current of 1.4 amps flows in the wire. How many electrons are flowing past any point in the wire? Okay, so this is some sort of equation. It's like a one-step equation for current in a wire, but there's probably a constant of permissivity. P. Okay, so the formula is I equals Q over T. I equals Q over T. And then Q is equal to I times T. The current is 1.6. And they're saying in 1 second, that means 1 second times 1. So that's 1.6. Then the number of electrons is Q over E. Okay, that same Q you just found, 1.6 over 1.6 times 10 to the minus 19. Oops, I'm using the wrong numbers. 1.4. That's that number, 1.4. 1.4 there. And then we got to get that value. So I have to do a little calculator work here to get it. I don't have mine out, so let me grab my calculator. Opened up. A billion other things open up, but not my calculator. So it's 1.4 divided by 1.6 times 10 to the minus 19. If you're doing it there, it's also got to be so 8.75 times 10 to the 18 is the number of electrons, which is, it seems really large, but electrons are quite small, so it's a reasonable one there. So there's two significant figures. You might go 8.8 times 10 to the 18 for your answer on that.
9.8 times 10 to the 18th. Is that what you said?
8.8.
8.8. All right. Times 10 to the 18th. That's correct.
18.09, is that one
Yes,
to go
sir.
to? Okay. Snip this in.
Okay. This is a frame piece between and it's on through the accent. And I need some.
Let me grab the reference question to compare to. I can find it. There it is. Problem 18, problem 9, problem 9. Okay. All right. So the we're trying to find R. R is equal to V over I. They give you V, 120 volts. They give you I, 13.5 amps. So you divide those and you get 8.9 ohms. And that's your final answer for that, for part A.
Is it one more?
Perfect. On the part B.
Part B. So part B is looking for Q. So Q in 12 minutes. So we know that I equals Q divided by T. So Q is equal to I times T. We know that I is 13.5, and we know that it's 12 minutes, but we have to convert minutes to seconds. So in 1 minute, there's 60 seconds. So you have to do this multiplication here to get the Q.
720 times 13.5.
Yes. 9,720.
1,720. What's the units?
Coulombs for
Yeah.
current. Or not for current. Coulombs for charge, which is what this is.
What does the symbol look like? Oh, just C. Okay.
Yeah.
I thought there was one like handy available, like the other one for ohms. I sent you another screenshot. A few others.
Okay. I think we got maybe one more of these in here.
Okay, no,
Oh no, that's an old one. Okay.
yeah, it's an old one. Here we go. Right about there.
So I'm not seeing a new question yet. I'm seeing something you sent maybe 6 minutes ago.
Just at 8.13.
Okay.
Just send both of them. I think we have enough time for both.
All right. So we got some pictures, new pictures here. All right. So we got 18.13. Do that one first, I guess. All right, 1813. Okay, the resistance is this rho value. That's a Greek letter 1 over A. They give you rho here. That's this number. The area you get from calculating it from the cross-sectional area of the wire. So the wire is considered to be a circle. Circle has an area of pi r squared. So you have that information here. So you have the diameter right there, and you can use that. So we're going to calculate the area. So the area is pi, and then your radius is 1.9 divided by 2. That's the conversion from diameter to radius. But then you got to undo the fact that it's in millimeters. Okay, so you have to multiply by 10 to the minus 3 in there. Then you square it, and you'll get a value for area. So we'll get that number. row we have here is that's the 1.68 times that. Now, this is for like a unit, and then we have to multiply this by the length. Okay, so we have this row value 1.68 times 10 to the minus 8, 1 over the A value that you're going to get over here, and then you're going to multiply it by 5.4. So I get some of these intermediate values, and then you can check your work. 0.9 divided by 2 times 10 to the minus 3 squared. All right, so the area over here is 9.70 times 10 to the minus 9. Let's see if that's the right reasonable. Yeah, that's reasonable. Okay, and then we're going to calculate R. So you're going to take this value, calculate it, you're going to store it and put it over here. 1.68 times 10 to the minus 8 times 1 over A times 5.4. Oops. Little snag there. Okay, so I end up getting 9.36 ohms, which seems kind of large.
That's all right, unfortunately.
.68 times 10 to the minus 8. 1 divided by A. A is pi r squared. Oh, there's my error. Okay, so I made an error in the area calculation 1.9. Okay, so this number is actually closer to 2.84 times 10 to the minus 6. And then I'll redo the calculation here. Okay, so that's a little close. That's more reasonable value. So you end up getting 3.2 times 10 to the minus 2 ohms. And that should do it for that one.
Correct. That's everything I want to do today. Thank you very
Great.
much,
Thanks,
Matthew.
Jack. I'll send out the notes to screen recording here shortly. Have a great day.
You too.
Bye now.